I'm sure that all of you who have visited qrset.com would have seen the Solar-Terrestrial Data Banner by N0NBH. I have also been seeing it for quite some time, but never bothered about it till the recent G5 Extreme Geomagnetic storm caused sudden radio blackout while we were having a nice roundtable chat on 7050 kHz at 6:55 am. I have seen the same banner from Paul's website being displayed at many other sites in different formats, courtesy the script and links provided by him. What you see here is a screenshot and not a live display, and I am giving a brief description to make it easier to understand, though most of it is self-explanatory. Date and time are displayed with time format as GMT, which stands for Greenwich Mean Time, also known as Coordinated Universal Time or UTC. UTC is also designated as Z or Zulu. Zulu stands for the Zero Zone GMT. In this banner, SFI 194 means solar flux index is 194. SFI is the amount of solar radio noise measured at 2800 MHz and is updated daily. It indicates the status of the F layer of the ionosphere in supporting HF communication, with numbers below 75 quite poor and those above 160 very good for propagation, typically from 20 to 10 meter bands. Next to SFI is SN or the sunspot number, which is also updated daily. It usually follows the SFI and is another indicator of ionization of the F layer. Here SN 166 is shown in green. Next comes the planetary A and K indices. Planetary A index is known as AP index, and it is the daily average of long-term stability of Earth's magnetic field taken from several locations. It uses the average of 8 3-hour K index values. Planetary K index or KP index indicates the short-term stability of Earth's magnetic field. NOAA Space Weather Prediction Center updates it every 3 hours. It has a range from 0 to 9, and values above 5 are unfavorable for radio propagation. In the recent G5 geomagnetic storm, the value was 9. The image shown here has a KP index of only 1, which is quite favorable. Solar X-ray emission, which impact the D layer of the ionosphere, comes next. It is mentioned in classes A, B, C, M and X, with A being the lowest, and scales from 0.0 to 9.9. In the image shown, it is C2.0. Stronger the radiation, lower the ability of radio waves to propagate by sky wave refraction. 304A gives the relative strength of the solar radiation at a wavelength of 304 angstroms or 30.4 nanometer, mainly emitted by ionized helium in the sun's photosphere. Here it is shown as at SEM, meaning that it is using data from SOHO, Solar and Heliospheric Observatory satellite using SEM or Solar Extreme Ultraviolet Monitor instrument. Other form of measurement available is by the Solar Dynamics Observatory using the EVE or Extreme Ultraviolet Variability Experiment instrument. 304A correlates with SFI and is responsible for about half of the ionization in the F layer of the ionosphere. Next two values displayed are the proton flux and electron flux reported by NOAA. Proton flux indicates the density of charged protons in the solar wind. Higher the number, more the impact on the ionosphere. Proton flux primarily impacts the E layer of the ionosphere. Electron flux is the density of charged electrons in the solar wind. Higher numbers have more impact on the ionosphere, that too primarily on the E layer. Aurora data is calculated from hemispheric power value, which varies from 0 to 150 gigawatt to give the old scale factor value from 0 to 10 plus plus. This indicates how strong the F layer ionization is in the polar regions. Higher values cause aurora to appear at more lower latitudes. Aurora latitude is a calculated value from 67.5 to less than 45.0, which estimates the lowest latitude impacted by an aurora event. This value is updated every 15 minutes and utilizes data from NOAA, National Oceanic and Atmospheric Administration of the United States of America. BSAT component was from the Advanced Composition Explorer satellite, which reports the strength and direction of interplanetary magnetic field as impacted by solar activity. Positive values are in the same direction as Earth's magnetic field, while negative values are of opposite polarity. Range is from plus 50 to minus 50. When the BZ component is negative, it cancels out Earth's magnetic field and increases the impact of solar particles in the ionosphere. Solar wind speed was reported from the same satellite as per Paul's website, though most likely both are from Discover, Deep Satellite Climate Observatory located at L1 Point, as NASA's Advanced Composition Explorer was succeeded by Discover after its launch in 2015. Higher solar wind speeds more than 500 km per second have impact on HF communications. If I remember correct, it was 700 km per second during the recent geomagnetic storm. Higher speed will also mean lesser lead prediction time after getting information from Discover, as it will reach Earth sooner from L1 position at around 1.5 million km from Earth. Next comes the VHF conditions, which are mostly self-explanatory. If aurora is reported as band closed, it means low or no auroral activity. High lat orb would mean auroral activity above 60 degrees north latitude. Mid lat orb would mean auroral activity from 60 to 30 degrees north latitude. ES stands for sporadic E-propagation. EU stands for Europe and NA for North America. Each of the bands can be reported closed or open depending on the situation. Earth-Moon-Earth degradation reports EME path attenuation as very poor, more than 5.5 dB, poor 4 dB, moderate 2.5 dB, good 1.5 dB, very good 1 dB, excellent less than 1 dB. Maximum usable frequency for sporadic E-propagation is presented in a colored bar. Gray is for no ES activity, blue supports 6 meter, green supports 4 meter, and yellow indicates 2 meter. Meteor scatter activity bar also is seen as a colored bar showing activity with respect to time in UTC. Gray indicates no activity. HF conditions by band and day and night needs no further explanation, and so is the current solar image. Geomagnetic field indicates how quiet or active the Earth's magnetic field is based on the K index value. It may be reported as inactive, very quiet, quiet, unsettled, active, minor storm, major storm, severe storm, or extreme storm. Higher levels can cause HF blackouts and auroral events as experienced recently. Aurora was noted even in India at Ladakh, 34 degrees north. Signal noise level is a calculated value which indicates how much noise in S units is generated by the interaction between the solar wind and the geomagnetic activity. More active and disturbed solar wind generates higher noise. Noise which one notices on the band is not just this, but includes many other types of noise. Even when this image showed S0 to S1, I had noticed S9 noise in my radio on 40 meter. It will also depend on your attenuator and preamplifier settings. What this image shows is only the contribution to noise from solar wind. Maximum usable frequency is an NOAA reported value from 0 to 100 MHz. It gives the maximum usable frequency in megahertz at one of 11 locations worldwide, and the data is updated once in 15 minutes. Solar flare probability within next 24 hours is expressed in percentage from 0 to 100%, and the data is from University of Bradford, updated every hour. I have tried to present what I have learned in a nutshell. Much more information and wonderful images are available at Paul's website, which you can go through in case you are interested in learning more.